Hello everyone, in this video I will be talking about problems on probability for this shift of September 11, 2020, shift 1. So in this first question I have been given three equations: 2x square plus x minus 1 is equals to 0, 3x square minus 10x plus 3 is equals to 0, and 6x square plus 11x minus 2 is equals to 0. And these equations have a roots which give the probability for the three events of a random experiment. But we know that quadratic equation usually has two roots. So how is it working in this case? You have to think maybe I will solve the equation first and then I will try to analyze what's going on. Just a minute, I had to close the window, too much noise. Okay, so let us first try to solve the equation 2x square plus x minus 1 equals to 0. So 2x square plus 2x minus x minus 1 is equals to 0. This gives you 2x into x plus 1 minus 1, x plus 1 equals to 0. So 2x minus 1 into x plus 1 is equal to 0. So x equals to half or x equals to minus 1. Minus 1 is not a probability. Probability can never be less than 0. So I reject it. So this is the probability for the first event, half. Let us look at the second equation. 3x square minus 10x plus 3 is equals to 0. Now factorize it like this. 3x common x minus 3 minus 1 common x minus 3. You can already tell that the factors, from the factors, that one root is equals to 1 by 3 and 3 probability is not greater than 1, so this is rejected. So 1 by 3 is the probability of the second event. Let us look at the third equation. Again factorize. Take 6x common, x plus 2 minus 1, 6x minus 1, x plus 2. So x equals to 1 by 6 or minus 2. Again probability not less than 0 is probability less than 0 not possible. So 1 by 6 is the probability. So the three events have the probabilities of 1 by 2, 1 by 3 and 1 by 6. If you add all of them up, what do you get? 6. 3 plus 2 plus 1. So it is equal to 1. So these three events capture all the possible probability, which is 1. So no other event is possible. Hence, exhaustive. We know exhaustive events are such that the outcome of the experiment, at least one of the events is going to happen. So since their sum is 1 for their probabilities, whenever you do the experiment, one of these events will be the output, one or the other of the three. So exhaustive. Second problem, cards are drawn one after the other without replacement from a well shuffled pack of cards until an ace appears. We know that in a pack of cards there are 52 cards, right? It's not mentioned, so you should remember out of 52, 4 cards are aces. That also you should remember. Okay, and if the probability that exactly 5 cards are drawn before the first ace appears is, so you have drawn 6 cards, first 5 are not aces, sixth card is ace, for which the probability is given, and they have asked something on these P1, P2. So let us first try to find out the probability for this event to happen. Since out of 52, 48 are not aces, and first card I draw and it's not an ace, so the probability is 48 by 52. And also you should take care that it says without replacement. So if I have drawn a card, I am not replacing it, so the number of cards reduced by 1, 57. And since I have drawn one card, the probability of not drawing an ace becomes 47 by 51. Why? Because the number of aces stay at 4 right? Because we have not drawn an ace. So number of non-ace is reduced to 47. Similarly, for the third card, it would be this. For the fourth card, it would be this. Fifth card, it would be this. Now, when it comes to the sixth card, I have drawn an ace. Number of aces are 4. So this is the total probability. And this is given equal to me as 4 by 49 into P1, P2, P3 by P4, P5, P6, and all these P1, P2, P3, P4, P5, P6 are prime numbers. So 4 by 49 I'm going to just remove, and P1, P2, P3, P4, P5, P6, let us not use this. 48 is cancelled. Okay, 47 is cancelled. I'm left with 46, 45, 44, 52, 51, 50. Are these the values which correspond to this? No, because it is given that all these P1 to P6 are prime numbers. 44 is not a prime. So let us reduce. 22, 26, okay, 11, 13. 11 is a prime number, 13 is a prime number. Over here, uh, mm, let's divide this by 5. So 9 and 10. Again, 3, 17. So 17 is a prime number and 3 is a prime number. Now we are left with 46 and 10. So 5, 23. I don't think there is any chance of factorizing any further. So 3, 5, 11, 13, 17, 23, all are prime numbers. But do I know which one is the P1, which one is P2, which one is P3? No, we don't. But they have asked a question, so like what's the maximum out of the 6 minus the minimum out of 6? So maximum and minimum can be just be seen from here. Maximum is 23 and minimum is 3. I don't need to know the values. 23 is the maximum out of all the p's and 3 is the minimum. So answer should be 20. 20. Okay, let us move on to the next problem. A number is selected at random from the set 1 to 100. 1 to 100. So there are 100 total numbers that are given to us. I'm selecting a number at randomly from this set. Given that the selected number is divisible by 2, so the set which is divisible by 2 is, we all know this, right? These are how many numbers? 50. 50 even numbers are selected. We are being asked the probability that is also divisible by 3 or 5. So the set of the numbers from 1 to 100 which is divisible by 3 is this, right? We'll go till 99. Now we are saying that it is given that the numbers are divisible by 2. So all the odd numbers are gone, right? So what is the set of numbers which is divisible by 6 in our given case? 6, 12, 18, 24, even 99 is gone. So 96 would be there. It's divisible by 2, 32, and is divisible by 2. So this is the set of numbers which is divisible by 3. This is the total number of options which are given to us, which is 50 numbers. So in our denominator of our probability solution, you will get 50, and it is clear from the option that 50 is there already. Now let us look at the set of numbers which are divisible by 5. So 5, 10, 15, 20, 25, 30, dot dot dot, 95, 100, 90. Now it is given that the number which is selected is divisible by 2. So even in this set, odd numbers are gone, right? So what is the remaining set? 10, 20, 30, 40, 90, 100. So when you say divisible by 3 or 5, what do? You just add these two sets and you get the total number. How many numbers are here in this? uh, 16, right? 16, and over here 10. So 16 plus 10 divided by total possibility is 50, or 26 by 50 should be your answer. It is already here, but in this problem we have made one mistake, that I have just added the numbers for 3 or 5, that this is the probability or this is the probability, and hence I have added them. But I have made one mistake, that when I look at this at 16, 6, 12, 18, 24, 30 is the next number, and 30 is here as well as here. So 30 has been counted twice. So I have to get rid of the number which are appearing in both the sets, right? So from the set of 5, 30, 60, 90, you can clearly see are all divisible by 3. This is 10, this is 20, this is 30 when divided by 3. Rest all are not divisible by 3. So 3 numbers are being double counted. So minus 3. So 23 by 50 is the solution. Okay, let us move on to the last problem on probability that was asked. A target is to be destroyed in a bombing exercise, and there is a 75% chance that a bomb will hit the target. So I'm hitting a target, and probability of bomb hitting it, so let us say that is bomb hitting is B, is 75%. So 75 is what? 75 by 100, or 3 by 4. Let us say probability of not hitting the target is given by Pn. So this will be equal to 1 minus Pb. Either I hit or I don't hit. So 1 minus 3 by 4 should be it, or 1 by 4. Now I have to assume that at least 2 direct hits are required to destroy the target completely. If I don't hit the target, it's not destroyed. If I hit it once, even then it's not destroyed. I have to hit the target twice at least. So what I have to find out is the minimum number of bombs to be dropped in order that the probability of destroying the target is not less than 99, not less than 99%, which means greater than equal to 99%. That is the probability of destroying the target. If destroying the target's probability is greater than equal to 99, then not destroying probability for not destroying the target is what? Is less than 1%. And you may ask, why am I looking at less than 1%? Why not try to solve from greater than equal to 99? I will let you know in a minute. Let us assume I'm dropping total number of n bombs. N bombs I have dropped. So if I have to destroy the target, I can either hit 2 bombs, or I can hit 3 bombs, or I can hit 4 bombs, 5 bombs, dot dot dot, n minus 1 bombs, and n bombs. So there are many number of cases I will have to look at in order to derive the probability and match it with greater than 99, greater than equal to 99% to arrive at the value of n. But if I look at this probability, all I have to do is either 0 bomb hit the target or 1 bomb hit the target. And that will give me the probability of not destroying the target, and I can use it by comparing it with this, and I can find the value of n very easily. Instead of this case where I have to do so many number of probabilities, add them and then find out, here I only add 2 probabilities and I find the value of n. So first probability 0 bombs hitting the target. What is this probability? I have n bombs, 1, 2, 3, 4, n, okay, and none of them hit. So probability of first bomb not hitting the target is what? 1 by 4. Probability of second bomb not hitting the target, 1 by 4. Third, not hitting, 1 by 4. Nth bomb, 1 by 4. So this is equal to 1 by 4 raised to the power n, or 1 by 4n, because 1 raised to the power n is 1. Now I have to find out the probability of one bomb hitting the target. Now we have to look carefully for this one, because it's not as easy as this one. Maybe the first bomb hits, right? First bomb hits. Second, no, no, no. Nth bomb, no. So what is the probability for this case? First bomb hitting the target 3 by 4, second not hitting 1 by 4, third not hitting 1 by 4, dot 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 1 by 4. If this is 3 by 4 is appearing once, 1 by 4 is appearing how many times? N minus 1, right? Because n are the total number of bombs. If 1 is hitting, then n minus 1 are the ones which are not hitting the target, which is also equal to 3 by 4 into 1 by 4 raised to the power n, or 3 divided by 4 raised to the power n. This can also happen in this way. First bomb doesn't hit the target, but the second bomb does. Third doesn't, fourth doesn't, last bomb doesn't. What is the probability in this case? 1 by 4 into 3 by 4 into 1 by 4 into 1 by 4 dot 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 into 1 by 4. So this is the same as this. 3 by 4 raised to the power n. There is another case. First doesn't hit, second doesn't hit, third bombs hit, then the rest of the bombs do not. The probability again is 3 by 4 raised to the power n. How many such cases are there? First bomb hits, or the second bomb hits, or the third bomb hits, or the n minus 1th bomb hits, or the n bombs hit, nth bomb hits. So total probability will be n times this. So 3n by 4 raised to the power n. Hence, the probability that either 0 bomb hits the target or 1 bomb hits the target is equal to, total probability is equal to 1 by 4 raised to the power n, which was here, that none of the bombs hit, or 3n by 4 raised to the power n, that is 1 bomb hits, and this has to be equal to less than 1%, as is asked in the problem. Now we have to solve for this equation and we will get the value of n. 3n plus 1 by 4 raised to the power n. 1% is what? 1 by 100. When I cross multiply, 4 raised to the power n is greater than 100 into 3n plus 1. Okay. If I take n equals to 1, what is this? 4. What is this? 3 plus 1, 4, 400. Not true. N equals to 2, this is 16, and this is what? 3 into 2, 6 plus 1, 7, 700. No. N equals to 3. You can straight away go for higher values and reduce your number of attempts to C, because we already know that it will not be applicable for 1, 2, 3, 4. But since I am explaining the problem, I have all the time with me. I'm not writing the exam right now. I have the liberty to do it. 4 raised to the power 3 is 64. You will not have time in the exam to do all this. But I have all the time I want. 3 times 3 is 9 plus 1 is 10. So 1000. 64 is not greater than 1000. N equals to 4. 4 raised to the power 4 is 256. 3 times 4 is 12 plus 1, 13. 1300, not true. N equals to 5. 1024. 5. 15 plus 1 is 16. 1600, not true. N equals to 6. This is what? 4096. And 6, 3 times 6 is 18 plus 1, 1900. True. So N equals to 6 is the correct answer. You have to drop at least 6 bombs so that your probability of destroying the target is greater than 99%. So these were the 4 problems on probability that were asked in this exam. If you have any doubt on any of these 4 questions, kindly let me know in the comment section. Thank you, everyone.